video lesson is going to look at our derivative of logarithmic functions. So we have, if you recall, we have just a general logarithm with any base given as log base b of x. We can also talk about the common logarithm or the natural logarithm. The common logarithm is going to follow this log base b formula. Natural log is going to be a little bit easier. So if you take the derivative of the logarithmic function, you end up with 1 over x, whatever your inside piece was here, and then log base b of e. Again, if you have chain rule, you might have to take the derivative of whatever was inside there. Natural log is a little bit easier because if you recall, log base natural log of e is just 1, and so we end up with just that simple derivative of 1 over u. Or if you've got u is something, then we can take the derivative of that with the chain rule. So for the most part, we're going to focus on natural log. That does tend to occur most often in application, but common logarithm does show up as well in things like Richter scale and decibels and those types of applications. So if we've got the natural log here, derivative is very simple. Y prime is going to be 1 over that 7x, and then we're going to multiply by the derivative of the 7x for the chain rule, and that just leaves us simply with 1 over x when we simplify. For the next example, we have log base 10, or the common logarithm, and so we're going to have to follow this first formula that we have up here. Our y prime is going to be 1 over the 4x minus 3, so it starts off the same. Difference here is that we multiply by the log base 10 of e, which is just a number. You could punch it into your calculator and find out what it is, and then we're going to take the derivative of the 4x minus 3, which is 4. So probably the easiest way to rewrite this would be 4 times log of e over 4x minus 3. Let's take a look at another example. We've got the natural log of x squared minus 5x plus 4. So we're going to, again, just do the 1 over that whole thing, x squared minus 5x plus 4. And then we're going to multiply by the derivative of the inside, which is 2x minus 5. And again, you can rewrite this as a single fraction, 2x minus 5 over x squared minus 5x plus 4. So I want you to take a second here, pause the video and try example 33. Notice this kind of puts both of these sections together. We've got the natural log, and then cosine is our inside function. So take a second here, pause the video, enter your answer, or write it down to enter later, and then resume the video, and we're going to look at example 34. So example 34 is a little bit more involved because we've got this fraction inside. But one of the really nice things about logarithms is that we can split that up so that division inside can just become subtraction outside. So instead of having to do the quotient rule or splitting things up and making the product rule, we can rewrite this as the natural log of x cubed minus the natural log of x squared plus 1. And now we just have a matter of subtraction. We don't have to worry about anything complicated. We could also use the laws of logarithms and bring this 3 down as a coefficient, and you'll see how that kind of works out in the end. So now we've got the derivative of the natural log of x cubed is going to be 1 over x cubed times the derivative of x cubed is 3x squared. And then minus derivative of the natural log of x squared plus 1 is going to be 1 over x squared plus 1. Derivative of our x squared plus 1 is going to be 2x. Again, to simplify, 3x squared divided by x cubed is just going to leave us with 3 over x. And then the second one just stays as 2x over x squared plus 1. So again, a lot simpler than having to worry about going through and doing the quotient rule. One more example here. We've got the natural log of the square root of 3x minus 2. So again, we could do the chain rule here. We can also do something here. So I'm going to rewrite this as the natural log of 3x minus 2 to the 1/2, because that's what our root gives us, a fractional exponent 1/2. And here I also want to say that we could, again, go through, do the chain rule multiple times, or we can use that property of logarithms and bring that 1/2 down to the front, so we get 1/2 natural log of 3x minus 2. If you notice up here, going back to the last example, I said we could have brought that 3 down out front, which would have given us a 3 times the derivative natural log of x, which would have been 1 over x, or 3 times 1 over x, which is 3 over x. So it does simplify and work out to be the same thing. So I'm going to do this both ways just to kind of prove that this is going to work out. First way here, we'll look at this one. We're going to take the derivative. So we've got 1 over this whole thing, 3x minus 2 to the 1/2. Then the derivative of the inside is going to have to deal with this 1/2. So we're going to have a 1/2, and then we leave the inside alone. Decrease the exponent by 1, and then we deal with the 3x minus 2. So the derivative of that is 3. So when we simplify here, we've got a 3x minus 2 to the negative 1/2, which is just 1 over that. So we can rewrite that. And since we've got it here twice in the fraction, we can combine those. We've got our 1/2 and our 3 here, so we'll put a 3/2 up top, and then just a 3x minus 2 here in the denominator. Again, you got a square root times a square root, just gives you what's inside. So that's one way to do it, or like I said, we can use that property of logarithms, bring that 1/2 to the front, and in that case we're going to have y prime is going to be 1/2 times 1 over our 3x minus 2, and then we just have to do the chain rule once, times 3. And you can see how this 3/2 ends up being here, and the 3x minus 2 is in the denominator. So two different ways of looking at the same thing. So this is going to conclude our video on derivatives of logarithms.